Hi, the topic of this video lesson is solving problems with cutting planes. Let's consider some geometric body, for example, such a prism. Let me remind you that the cutting plane is the plane that passes through the geometric body, and on both sides of which there are points that belong to this geometric body. For example, we have such a plane. It passes through the given body. And there are points that belong to this geometric body on both sides of this plane. Then we say that this plane will be a cutting. This cutting plane passes through the faces of this body at some intervals. For example, such intervals in this case. Then, if we connect the intersection points of these intervals, then we'll get some polygon. This polygon will be called a section of a geometric body by a given plane. We can get different shapes depending on how many faces the body has. Since the tetrahedron has 4 faces, it can have either a triangle or a quadrangle in section. A parallelepiped has 6 faces, which means that the section can turn out to be a triangle, a quadrangle, a pentagon, or a hexagon. Let's try to build a section. Let's suppose we have a tetrahedron. As a rule, we can get some points for problems with sections and additional conditions, according to which this section must be built. In our case, the condition is points are marked on the tetrahedron. Let's say a point is here. A point on the edges of the tetrahedron is here. And let's say a point is here. It is required to draw a section that passes through these points. Let's denote, for convenience, DABC. As a rule, in order to build a section, proceed as follows. We need to use the points that lie on one face. For example, these 2 points. Let's denote M, N, and P. Points M and N both lie on the back face, BAD. If they lie on the same face, then I can connect them. So we connect them. And let's continue. Since they lie on the far plane, it is obvious that the line MN is not parallel to the line AB, and they lie on the same plane, so they intersect somewhere. They will intersect outside the tetrahedron. Continue AB, continue MN. They intersect at some point. This point now lies on the bottom face, both on the back and on the bottom face. This point and the point P lie on the bottom face, which means that I can connect them too. And I continue until the intersection with the edge BC. Then I get one more point on the edge BC. Let's say point F. Now we look at the points N and F. They both lie on the right side, so I can connect them. P and F have already been connected. Now point M and point P also lie on the same face, on the left of face DAC. I can also connect them. Thus I got a quadrilateral P, M, N, F. This quadrilateral will be a section of this tetrahedron, passing through the points M, N, and P. That is, the main idea is that we have to connect points and continue them until they intersect with some lines, connected points that lie on the same face. Let's take a look at another example. Let's have a tetrahedron again. DABC. And let there be some point M that lies on the face DAB. That is somewhere here. It is required to draw a plane, section, to the point M, which will be parallel to the plane ABC. How can we do this? Let's consider the plane DAB. M lies in this plane. Now, to draw a section that is parallel to plane ABC, I draw a line in this plane, passing through point M and parallel to AB. I have drawn a line. It intersects edges DB and DA at some points. Let's denote these points as E and F. Point F lies on the right face BDC now. I draw a straight line from point F in that face that is parallel to BC. I've got some point K. It remains to connect E and K, which lie on the back face. Thus I've got a triangle EFK. This triangle will be a section which passes through the point M, parallel to the plane ABC. Now let's try to build a section of a parallelepiped. We can get completely different things, depending on the location of the points through which we need to draw a section. For example, in this case, we have the parallelepiped ABCD. A1, B1, C1, D1, A1, B1, C1, D1. It is required to draw a plane passing through the points K, V, and M. It is required to build a section. In this case, it will be quite simple to build a section. We just need to connect all these 3 points. K and V lie in the same plane. We connect them. We connect M and V as well. K and M both on the bottom. Connect them. We've got such a triangle, KVM. This triangle will be a section of this parallelepiped. Now let's consider another example. Let's suppose we have such a parallelepiped, and the points MN and K are located on it as follows. We need to build the section again. It will be a bit more difficult this time. Side A, A1, D1, D, and connect the points M and N, which lie on this side. The line is not visible here, therefore it is dashed. I continue this line. Since the line MT and the line AD lie in the same plane, and it's obvious that they are not parallel, then they will intersect at some point. This point will go outside the parallelepiped. We've got this point. We connect N and K in the same way. They lie in the far plane, so they will intersect D and C. This is a straight line. That is, if we connect it and continue, then this line will intersect the line DC at some point. Here we have point A. Now the 2 points that we've got, they both lie on the bottom face, so we can connect them. Now connecting these lines, we've got that this line crossed the edges AB and BC at some 2 points. Let's denote these points as E and F. It remains to connect M and E. E, F has been already connected. Let's make it clearly visible. I will connect them with a solid line, but actually it should be dashed. We connect F and K, they lie on the lateral face. We connect N and K, and M and N. We've got such a pentagon. This pentagon will be a section of this parallelepiped, passing through the points M, N, and K. This video lesson is over.